Hello friends, the name reaction for our syllabus. The first reaction is stopic condensation. Stopic condensation, if we try to define it, it is aldol condensation type of the reaction of carbonyl compounds. When aldehyde or ketone react in presence of dialkyl succinate and strong base gives unsaturated monoester. This reaction is known as Staube condensation. So here, aldehyde or ketone, dialkyl succinate, specifically diethyl succinate, and this is monoester. So monoester means there are two ester groups in reactant, but out of two, one is converted into acid and one ester remains as it is. So benzophenone react with diethyl succinate in presence of sodium ethoxide to give unsaturated monoester. This reaction is known as Staube condensation. Generally, these reactions have very high yield, that is 80 to 94%. This is another example where acetophenone reacts with diethyl succinate and gives monoester. So, what is the mechanism of this reaction? Diethyl succinate, when comes in contact with base, this base abstracts one of the proton from either of these carbons and it generates a negative charge on the carbon that is known as carbanion. This carbanion is resonance stabilized. That means negative charge can form double bond here and this carbonyl double bond can be converted into negative charged and the vice versa. So this negative charge can come back to form carbon oxygen double bond and this carbon carbon double bond can come back to form negative charge on the carbon. This is known as a resonance stabilization. And if a resonance stabilization is there, the carbanion is stable one. So it can be easily formed. That means the reason behind easily formation of this carbanion is in the acidity of these protons. So these are labile protons, acidic protons, and can be easily removed by this strong base sodium ethoxide. So this carbanion formed further in the next step attacks on the carbonyl carbon of the carbonyl compound and adduct is formed. This adduct is nothing but addition product. All all the structure remains as it is, but only carbon carbon bond formation is happened here. And this adduct further intramolecularly intramolecular attack. That means within the molecule, this negative charge on the oxygen attacks on the carbonyl carbon of the compound within the molecule. So this is known as intramolecular attack of oxyanion on the carbonyl carbon. This gives rise to cyclic structure, five-membered ring structure And this five-membered ring structure further eliminates this ethoxide ion OET minus or OC2H5 minus. And this removal of this ethoxide ion generate this carbon oxygen double bond, and this structure is known as gamma lactone. This gamma lactone further in presence of strong base eliminates this proton and gives rise to carbanion. This carbanion intramolecularly attacks or it forms double bond, and the ring structure is diminished, or we can say ring is broken and open chain structure is formed. This open chain structure further upon protonation in presence of acid gives one acidic functionality and one ester functionality in the product, and this is known as unsaturated ester acid or unsaturated monoester. It is also known as unsaturated monoester or unsaturated ester acid. This is the final product, and it is formed by the mechanism. So, synthetic applications of the Staube condensation. The final condensation product of the reaction, unsaturated ester acid, may be decarboxylated. That means CO2 can be removed. Removal of CO2 is known as decarboxylation with the help of hydrobromic acid HBr in presence of acetic acid gives beta gamma unsaturated acid. So this is the product of Staube condensation, and this upon reaction with HBr in presence of acetic acid gives this alpha, beta and gamma. So beta gamma unsaturated acid. This beta gamma unsaturated acid can be hydrogenated to saturated acid by hydrogen in presence of copper chromate Cr2O3 CuO, and this saturated product or saturated acid can be obtained. These are the synthetic applications of Staube condensation for our syllabus. Thank you.